All right. So let's have a quick review. Okay. So the first concept that we really learn is linear combination. So given a set of vectors, you want u2 up to um, and if you give it a real numbers, m real numbers, and if you multiply each of the vector with these numbers, and then you combine it, you take the sum. We call this a linear combination. Okay. All right. So given a few maybe on the exercise, you given three vectors u1, u2, u3, and you would like to check if vector 1, 0, 0 is a linear combination of those vectors. So let's look at the exercise. You are given three vectors u1, u2, u3, and you want to check if vector 1, 0, 0 is a linear combination of these three. Okay. So to understand that, so we would like to say that vectors 0, 1, 0, 1, 0, 0, okay, is a linear combination of these vectors if there exist these three numbers, right? Alpha 1, 2, and 3, such that this guy equals alpha 1, u1. So let me write u1 right away, plus alpha 2 times 0, 1, 2 plus alpha 3, 1, 0, 1. Okay, so let me zoom in a little bit. Okay, we would like to find, so currently, what are the unknowns? The unknowns are these, right? These variables, these three variables. Okay, we want to find these three unknowns so that this equation holds. Okay, so can you write that as a system of uh, linear equations? Can you do that? So this is basically, let me rewrite it again. This is basically a vectors equation. So this is alpha 1 times 1, 2, 0, right? Plus same thing, right? This is equivalent to 0, 1, 2 plus alpha 3, and this equals to 1, 0, 0. Okay? Same thing, okay? I only write a vector in instead of just using a list form, I just write it as column vectors. Okay? Okay. From this, can you express this vector equation as a system of three linear equations? Okay. Write it down. Okay. Write down the system of linear equations for this, and then solve for alpha 1, 2, and 3. If you can solve for alpha 1, 2, and 3, that means 1, 0, 0 is the linear combination of these three vectors. Okay? So can you write down the system of linear equations? Okay, so let me write down the first equation for you. Right. The system of linear equation is, so the first row is going to be, if you don't really like alpha, you can write x, it's okay. So it's going to be alpha 1 plus 0, right? So I just leave it out. 0 times alpha 2, so plus alpha 3 equals 1. This is the first equation. This is 0, right? Can you write down the other two? Can you write down the other two equations? And can you solve it for alpha 1, 2, and 3? Let's do it. Okay? So the other two equations are, what are they? So it's going to be 2 alpha 1 plus alpha 2 equals 0. And finally, 2 alpha 2 plus alpha 3 equals 0. Right? Okay, so can you solve for the value of alpha 1, 2, and 3? Can you solve that? You can use Gaussian elimination, but you can just do whatever you like. So let me try to do that really quickly, okay? So let's call this equation 1, 2, and 3. Okay, so you can have, I need to cancel this out, right? So basically I just subtract. Okay, so it's going to be 2 minus 2 times equation 1. And then I get, what do I get? I get alpha 2 minus 2 alpha 3 equals minus 1. Minus 2, sorry. Minus 2. And then I have this equation and this equation. So I can multiply this by 2 and just subtract that. So I get equation 3, let's call this equation 4. So 3 minus 2 times 4. I get, I cancel this out and I get alpha 3 minus 2 times 2, right? So it's going to be 4 alpha 3, so I get 5 alpha 3 equal 4. It's minus 2 times minus 2, I get 4. So I get that alpha 3 equals 4 over 5. Okay? And then alpha 1. So I can plug them back, okay, to figure out. Now I get alpha 4 is 4 over 5. And I know that alpha 1 plus alpha 3 is 1. So alpha 1 is 1 over 5. Okay? And finally, alpha 2 is basically minus 2 over 5. Okay? So after we get this, we can plug them in. Okay? I can plug them in. That's okay. 1 over 5 times 1 2 zeros plus minus 2 over 5 0 1 2 plus 4 over 5 1 2 1. Okay, let's see if it's correct. So 1, okay, 1 over 5 minus 2 over 5 plus 2 over 5, okay, that's okay, 2 over 5. Yeah, okay, that's correct. So now, okay, after we solve for alpha 1, 2, and 3, we have this equation. Okay, so let me stress out again. So we have 3 vectors, u1. Okay, let me zoom in. We have 3 vectors in yellow, and then I multiply each of the vector with some numbers, 1 over 5, 2 over 5, minus 2 over 5, 4 over 5, and I get these vectors that I in blue. Okay, so this means this vector, okay, the last one is a linear combination of these 3 vectors. Okay, because you can show that you can combine these 3 vectors linearly. What I mean by linearly is like I scale them, right? I scale some of these 3 vectors and then I just add them up and I get this one. So this one is a linear combination of that 3. Okay? So this is basically the definition of linear combination. Okay? So a linear combination is sort of like you haveอยู่ด้านหลังครับด้านหลัง Okay. Okay, so this is a quick review on linear combination. But if you have a set of vectors, so let's look at the next one. The second problem, you have 3 vectors, v1, v2, and v3. 1, 2, and 3. And we can, with these 3 vectors, we can have a lot of linear combinations of these three vectors. Okay, if you take all linear combinations, we get what we call a span. Okay, a span of this set of vectors is the set of all linear combination of these three vectors. Okay, so the second question is ask you to check this bunch of vectors and check if they are in the span of these three vectors or not. Okay, so for a vector to be in a span, it has to be a linear combination of these three vectors. Okay, so if it's in the span, you should be able to say like this number is, this one is in the span because blah 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 something. Okay, so can you check all the vectors? So let's try to save some time. Okay, so you should pick a few of the vectors. Not you don't have to do all of them. Okay, just for practice, should pick like a few of them and to check if they are in the span of this or not. Okay, but let me try to help you a little bit really quickly. Okay, we have three vectors. Okay, vector 1 and vector 2. Okay, what can you say about vector 3 v3? Is it a linear combination of the first two vectors? Actually, keep thinking up. Is it a linear combination of the first two vectors? Can you get v3 by combining v1 and v2 linearly? Yes, right? Because you see why? Because this v3 equals basically 1, 1, 0 plus minus, right? So 1, 1, right? Because if you subtract this from that, you get 0 and minus 1, right? So span of v1, v2, v3 is going to be equal to span of v1 and v2. Because adding v3 doesn't really help you in any way, right? Because anything that are spanned by v1, v2, v3 is also spanned by v1 and v2 because v3 is just a linear combination of v1 and v2. Okay. So to check all these vectors, if it belongs to the span of v1, v2, v3, we only need to check if it belongs to span v1 and v2. Okay. So let's try to see the first one. 1, 2, 1, is it in the span of v1 and v2? Yes, so you can say this is belong to the span, right? Is 1, 3, 1 in the span? Can you get 1, 3, 1? You probably can't, because you think about this. This is 1 and 1, right? So to get 1 in the first column, you need 1 unit of v1, right? To get 1 on the last column, you need 1 unit of v2, right? And then and that's it. You only have two vectors, so you can get 1, 2, 1, but you cannot get 1, 3, 1. So this is not in the span. Okay. Try to work on this. Okay. And when you want to say this one is in span, so let's say write it like this: v1, v2. So 1, 2, 1 is in span because it's v1 plus 0, 1, 1, right? Okay. This one is not, so you can just skip. Is it in the span? 1, 3, 2, is it in the span? Yes, right? So you write 1, 3, 2 is in the span because blah 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 blah. Is this in the span? No, right? This is not. So let me, this is in the span. This is not. I think this is it. This is in the span. This is in the span. This one is not. I think. This one is also not. I don't think so. -2, -2. So it's not. Okay. So you need to write down this one, -1, -2, -1, so equal something, and also 0, 0, 0. Okay. So do this, and do this. Other vectors not in span V1. Okay? Do this really quickly. Then we'll come back and talk about new topics for today.